Bertie, what are you doing?
站起来一下。
Stretching. And this is microns, this is spec. So going to calculate the specification, the probability. The x is extrapolate the upper bound, 2.0. Or, so you can see that the or the lower than 1.0, right? So this is called the process fallout. The process fallout. Either greater than or smaller than. 这个是家乐福买得到吗？有没有特殊的 ingredient， 就是巧克力，还是 OK sure. Nice. So try to get one. Nice. Then x greater than 2.0, x smaller than 1.0. So we do the standardization or standardization in order to get z value. So the probability x. So what is the mean? So 1.5, 0 something, right? So the number is x double bar. X double bar, right here. 1.5056. Divide by standard deviation. What is standard deviation? Or sigma divided by where? Hold on. This one, sigma 0.1398. Greater than 2 minus 1.5056 divided by 0.1398. So on the left hand side, so what is this? This is z greater than something, right? Plus the probability doing the same. The z is smaller than something. I'm going to copy it later. Probability. I'm sorry. Plus the probability, the x minus 1.5056 divided by 0.1398 less than 1. 0 minus 5056 divided by 1398. So after home calculation, so this is a z. Will anybody get this value for me? This is 3 point something. 3 point. Hold on. Greater 2.0. 3.553. And the last then minus 3.61. So then we like to get this. So first first probability is greater than 5.53, so go to 1 minus 5. This is CDF of that. So 3.53 plus. The second probability is a 5 and minus 2.61. Okay. So I just use only 2 digits after decimal. Minus, probably around 0.00035. So this is about what ppm? 1, 2, 3. Right? 1, 2, 3, 4, 5. Yeah, 350 ppm. So this is about the 0.03%. This is 350 parts per million. Multiplied by 1 million. This is ppm. So of the wafer produced will be outside the specification. Only 0.035%. So every 1 million produced, how many will be out of the spec? How many? Going to be have 350 wafer will be produced out of the spec. Question? Banzang, any question? No? No, good. So, then, so this is called the process flow out. Then we move on. So another way to express the process capability is in terms of the process capability ratio. Please see that. Potential process capability is also indicated by the process capability. CP. So this is called the potential capability. That is defined the upper specification limit and the lower specification limit divided by 6. So in the numerator, what is the upper specification limit and lower specification limit? Gentlemen? In which case, what is the UCL and LCL? Do you follow me? Gentlemen? Yes. So what is a UCL and LCL? The gentlemen? Hello? Hello? What is a UCL and LCL in such a case? Mr. Christmas Tree?
Yes.
So what is a UCL and LCL for this space?
UCL is 1.6932，那 LCL 是1.3179。
Okay, I mean specification limit. Not control limit, specification limit. USL, LSL. upper specification limit and lower specification limit. 2.0 and 1.0. Yeah. 2.0. So 6 sigma. Where can we get the sigma from? Gentlemen? Gentlemen? Sigma. 说话用说的。How can we get this number? How can we get the sigma? 年轻人喝这个是可以。Yeah, that's great. You have a drink like that. So where do you get this number? Yes, please. R divided by D2, right? Okay, so what is the number? 0.19. 0.19 and then?
3.
What?
1398.
1398. Thank you. 1398. So finally it turned out to 1.192.
Which is
1.192. So what is the number representing? What is the number representing? What do you say? Okay. Our Miss COW. What is number representing? Is this number telling us something we already know? Find out. Okay, can you explain what is the number? What is it indicate something? 这个数字代表什么意思 ？OK， 学员鼓掌，来表现一下。Yes. Yes. 来画眉鸟，来试试看。来金丝雀。Okay. Or Toronto Blue Jays, or the St. Louis Cardinals. Yeah, there's a three different birds in Major League, right? Toronto Blue Jay, and the Cardinals, and there's another bird, right, in Major League. Let me see that. Nationally, what kind of bird? Oh yeah, Orioles, Baltimore Orioles. The three birds. 精英队啊，你们只会讲精英，不知道精英怎么讲 Oriole，right？ 精英在哪里？巴尔的摩，巴尔的摩在哪里？什么州？马里兰州，是不是？只会看棒球，啥都不知道。以前我们的选手谁在那边打过球？新的郑伟英，对不对？薪水小偷，对不对？对。So, what is this number representing, gentlemen? What do you think? It indicates the process capable, potentially capable. Yes.
不要听 IATI
不小心。
Potentially capable. What? Look at this. This is upper continuum. Well, this is upper I'm sorry. The upper I'm sorry. Still be that. Lower specification limit. It's the upper specification limit is this way. And what about that? Divide by 6 sigma. This divide this equal to 1.1 something, right? So the denominator should be more compact. or smaller than this width, right? Something like this. Am I right? And this smaller than that, the ratio will be larger than 1.0. So,
有一点
distribution will potentially be like this. So if the center has been qualified or well adjusted, most of the process will be produced, most of the product produced will be within the upper specification limit and lower specification limit. Now we are saying it is potentially feasible,
没有
right? So, however, if the center is not well adjusted, might be like this, then there will be the potential. There will be potential process fallout. So in which case we only can say the process is only potentially favorable if the center is well adjusted. So if this number is greater than 1.0, so by the FORD, FORD. So we expect that CP is much greater than 1.0. This is by the rule of thumb. Do you know what the FORD is? FORD. COW? FORD. You don't know what FORD is? Jingyi. FORD you don't know. How about you? FORD? Do you know FORD? It has an automobile company. FORD.
Oh, Ford.
Automobile company. Ford is a fix or repair daily. So in America, we buy a car, Ford car, we say it is a fix or repair daily. It's a joke. That's a joke. However, the Ford is it's much better than that. I think the Kuga is a bestseller, right? Then, gentlemen, do you get it? Gentlemen, do you get what I'm saying? So 1.192, this is rise. The natural torus limit. The denominator is natural torus limit, 6 sigma. Center to the right, center to the left, 3 standard deviation. So you're going to cover how many standard deviation? 6. So stand for the natural torus limit. Press you.
没有，
到时候有。
有一点。
对。
Natural torus limit.
给他问一下他们。
是自己没带。
The process 3 sigma above below are within the lower spectrum and the upper stop. This is indicated by the blue shape. If we lucky enough, they're going to fall within the upper specification limit and lower specification limit. If we lucky enough. So, consequently, a moderately small number of non-conforming wafer will be produced. What is the potential? What is the potential? Only 0.035% will be produced out of the control specification limit. Okay. Fair enough? Okay, cool. Then, so the PCR process capability ratio CP may be interpreted another way. So we calculate the P, take the reciprocal. So 1 over CP
EX 开头。
1 over CP that is representing
POD
83.89. percent. So it's simply the percentage of the specification limit that the process used up. So look at that. This is 100%, and for the natural tolerance limit, how much percentage has been used up by the process? 83% only 83% has been used by the current process. So, so for the hard bake, it's about 83.89. So that is to say process used up above the 45. We still have a tolerance. We have some room. We have a 16% remaining, never being used up. This additional, we call the cushion, that remains. Okay, then 6.3, take it. On the bottom of page 225. Question, gentlemen? Get it? No? Okay, cool. That's cool. Mr. CHENG, the powerful one. Okay, powerful one. Our universal team, right? Universal team. So you're going to focus. Okay. So process for and the process capability, A. B, CP greater than 1. Look at that. Why is it greater than 1? The gentleman? Yes. Why is this greater than 1? Can you tell? Gentlemen? Yes. Okay, correct. Since the upper specification limit and lower is wider, we only use that portion of that. This is the upper natural tolerance limit. This is the lower natural tolerance limit. The natural tolerance limit. And only portion of that has been used up. What about that? Gentlemen, continue. This one. The barely make it. The upper natural tolerance limit and lower natural tolerance limit. The almost exactly meet the upper specification and lower specification. So CP barely make 1.0. Then, no, this is totally not capable. Okay, our customer requires this. However, you produce this Y. Of course, there's a big portion will be the process fallout, which is totally unacceptable. Unacceptable. 好，想睡觉啊？那去走一走，去喝水。你昨天几点钟睡啊？说。一点就干嘛？又在玩手游还是看什么小鸭影音？对呀，怎么跟我一起看小鸭影音呢？我也在看啊。这一本，没礼貌，长那么大没那么好看。Okay, page 2 to 6. Page 2 to 6. Then, revision of the control limit and center line. The effectiveness,
就是用这个算。
effective use of any control chart will require periodic revision of the control limit and the center line. So we're going to check from time to time. And some practitioners establish the regular periods for review and the revision of the control limits, such as every week or every month, or every 25, 50, or 100 sample, and so on and so forth. So sometimes the user will replace the center line X bar with the target. So I'm going to replace the X double bar.
有一天不会。
So the center line typically is used X double bar as a center for the target. Target is known as a nominal. The nominal value. The setup time, we really want to get that. The target typically on the center. Of the specification level.
这个
The center, there's upper spec and lower spec, and there should be some center. 可以吃啊，这虽然是我早餐，你可以吃啊，没问题。
好大方。
对 ，yes. And target value. So if R chart exhibit control, this can be helpful in shifting the process average to the desired value. Since if the R is stable, since we are doing fine. Since R is the information of reflecting how stable of the process, the current process is. So adjustment of the manipulatable value in the process. The process, if the mean is not easily influenced by the simple process adjustment, then it likely to be a comparison and quite unknown function of the several process variables. So a target value may not be that helpful. So it is cannot be directly to adjust into the target. So we might use a run-to-run control. So this is back in the 1990s, is a quite famous control scheme called the run-to-run control. So it is only eligible when if the process mean is not easily influenced by the simple process adjustment, then is it likely to be a complex unknown function of the several process variable like this. So as a use of the value resulting in many point outside the control limit, such as we will not necessarily know whether the point is actually associated with something. So in such a case, we need to adjust from batch to batch, from wafer to wafer, or run to run. So would not necessarily know whether the point value was really associated with some pulse or not. Then it's probably outside the limit because of the full control of the center line. So this, in which case, this is known as an EPC. This is an online. Here's it. By the control. Belong to the engineering process control. Or you can adjust it. Sometimes you can adjust it from run to run. Then if you don't want to do so, we'll like to adjust the process really back to the center. Can use the offline quality control. like there's another way which allowed us to do so. Is design of experiment. Called DOE, design of experiment. So there's two ways. We can use it online, use a run-to-run, try to adjust it back to the sensor if it is possible, or if it's still not possible, then we like to do so that is called the process improvement. The purpose of which is referred to the process improvement. This is the process improvement. And this is referred to the process adjustment. The different philosophies. The process adjustment and the process improvement.
这书呢？那是书啊。Yeah, I know.
So the help will determine, which process available to adjust the value of the process design experiment. Okay, when R chart is out of control, it is a worst case. We often eliminate out of control point and recompute a revised value of R. This value then used to determine new limits and the center line on the R chart and the new limits on the X bar chart as well. So if in R, there's an outlier found. If a sample can be confirmed, then that outlier should be removed, should be got rid of. Then we recompute the R bar divided by D2. That point has been removed. We recompute R bar. The R bar divided by D2 is used to re-estimate the sigma. Then the center, the standard is still the same, and the upper control limit and lower control limit for the X bar chart should be recomputed. So that will usually tighten the limit on both charts. So if the outlier has been removed, gentlemen, outlier has been removed, and how about the control limit about the X bar chart? Going to get the wider or looser or tighter? If we remove the outlier, then the control limit for the X bar chart will get wider or get tighter. Which one should be? The sister, the older sister or the twin? Wider? Why? The outlier has been removed. Variability has been reduced. Get tighter. Why does it get wider? No way, since the outlier has been removed. So variability reduced. So you need to get tighter. Right? Tighter. Gentlemen, get it? Why do you get tighter? Hello. 等一下，你的眼睛怎么红？昨天进羊水。
昨天12点。
在干嘛？在干嘛？
应该是那个吧，因为喉咙也有点痛痛，可能没有啊。
Okay then. So this value then used to determine new limit, center line on the R chart, and the new limits on the X bar chart. So R center line upper lower should be updated correspondingly X double bar, no change. And X bar, the upper control limit, lower control limit of X bar should be updated correspondingly. So they usually tighten the limit on both chart, making them consistent with the process and navigation that reflect the use of revised R chart. So in the relationship of R bar divided by D2. And the estimate sigma can be used as a basis of preliminary analysis of process capability, and the sigma head has been updated, and the PCR process capability ratio should be updated as well. All the information should be updated. Okay, phase 2. Okay, page 2 to 6, the bottom of the page 2 to 6, operation of the X bar and R chart. So use of control chart for monitoring future production. So the purpose of the phase 1 construct the limitary control limit, and to identify possible outlier. If there's an outlier, remove it and reconstruct the limits and proceed to process 2, phase 2. Once a set of reliable limits are established, it is called a phase 2 of control chart usage, figure 6.4. On the bottom of the page 2 to 7, you see that? Also put the control limit in online. Put the control chart online. Then a round chart showing individuals' observations in each sample called the current chart or the tier diagram in figure 6.5. So a round chart showing individuals, saying that each sample how many individual we have? 5, right? Originally set up the n equal to 5. So there's a future may reveal pattern of the unusual observation in the data. So this is an example. Then what do you see? Something on this chart, what do you see? Here, this is in the borderline. It's quite risky. Actually, it's still not extrapolate. And how about that? There's a pattern that after 35. Yeah, there's a trending, right? Going up. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Now you go out of the upper bound. You go out of the upper bound. Look at the statement. So, okay, look at that. Originally we have a sample. So, look at the sample. Originally, how many sample we have? 25. Since we already go on, right? So we collect starting from 26 until 45. So this additionally 20, right? Originally 25, then we already confirmed the process in control. So control chart goes on, right? Yeah. We starting 26. Then we calculate R, and we calculate X. So this is XI, 26, and plot in here.
这是画的。
Right here, 26. Corresponding to 26 right here. So this is X bar, and those information are plotted in here and in here, starting 26 to 45, right? To 45. So that phase is called the phase 2 of control chart. Question? Any question? Okay. Done. This is a tier chart constructed using the minutehead function. So look at the page 2 today. There's two distributions. One 5056 starting in this lower specification limit at 1.0 micron, upper specification limit at the 2.00 micron. The two distribution 15056. So where does this number come from? 15056. 15056. Right here. 150, yeah, right in here, right? 15056. This is a phase 1, right? Phase 1. The mean of the phase 1. And what do you say? 16633, phase 2. So the mean just shifted a little bit. There's a mean shift, right? So it's all right in here, around the 40 to 50, 45. Suddenly, some point shifted up to a higher level, we call the mean shift. There's a mean shift. So the tier chart of the flow with data observation shown in the figure 6.5, the chart does not indicate that the auto control signal will generate about the unusually individual observation, but instead, they probably result from a shift, which highlighted. You highlighted. Shift. You see that? Shift in the mean around the time that the sample 38 was taken. The mean shift starting right here. 38, 39, 38, 39, 40, boom, and keep going. Okay, then this is what we see. Then, control limit versus specification limit. Okay, take a break.
你家人，你是跟谁住啊？是遛狗。你是什么狗啊？啊？家里养还是你养？
是白菜、黑菜。
规格，
或者长大。
你今天没有跟我们知道。
哦，那是豆菜啊，这是豆菜。